Should you let an AI agent run loose on your machine? Well, that's the question developers everywhere are grappling with. The thing is, AI agents are powerful in all senses of that word. They can get a lot done for you, but they've also been known to get things very, very wrong. There have been instances of coding agents mistakenly deleting users' files or exposing user credentials to a malicious actor. And if you have to babysit it like an overeager intern, you're losing half the point of having an agent in the first place. Docker is tackling this problem with a new product called Docker Sandbox. So let's take a look at what it is, how it aims to solve these problems, and the trade-offs involved in using it. If you've used coding agents, you've probably seen this particular problem: the constant need for attention and permissions. Agents were supposed to offload work from us, but instead it's asking us for permissions to do anything and everything. So why is it set up to be so tedious? Well, the answer is that you are the circuit breaker from the risks of your agents going rogue. We've seen cases where an agent decides to start from scratch, so it runs rm-rf on your project, or even worse, your whole root directory. One small stumble for the agent, one giant heap of pain for the user. Second, your agent needs credentials. That means API keys, GitHub tokens, environment variables, and so on. A malicious dependency or a prompt injection, and those keys are gone. And this isn't hypothetical. In February 2026, researchers found vulnerabilities in Claude Code that could exfiltrate API keys and execute arbitrary code, and OpenClaws Marketplace has hundreds of malicious packages. All these risks are why permission prompts exist, and also why running AI agents with auto-accept is called YOLO mode. And all this is why Docker is building sandboxes specifically for AI agents. The main job of a sandbox is to be a protective layer between your agent and the host machine. What Docker Sandbox does is by wrapping your AI agent in a virtual machine that is isolated from your host device, and putting together additional quality of life improvements for using those coding agents. Now, you might be thinking, wait, Docker already has containers. Why not just run the agent in a container? It's a fair question, and it's actually where Docker Sandbox initially started. But there are a few reasons why they moved away from this in Docker Desktop 4.58 onwards. The first is the kernel. Containers share the host kernel with the OS. They just isolate the file system and processors on top of it. That means any kernel level exploit inside the container hits your host OS directly. For a web server, maybe that's an acceptable trade-off, but for an AI agent running arbitrary code on your device, less so. The second problem is Docker itself. Coding agents need to do things like Docker build, run testing containers, spin up services with Docker Compose, and so on. But if your agent is already inside a container, how does it run Docker commands? Well, as it turns out, you've got two not great options. The first is Docker in Docker, which runs the container in privileged mode. This unfortunately tears down the isolation that you're trying to create in the first place. The second option is to mount the Docker socket from the host. This gives the agent direct access to every container and volume on your machine. That's arguably worse. As a result, Docker went with virtual machines or VMs. A VM gives you deeper levels of isolation than containers by owning its own entire operating system on virtualized hardware. Think Parallels or VMware running Windows on your Mac. A piece of software called a hypervisor acts as the middleman between the guest OS and the real hardware. Your host OS and everything on it is fully insulated from anything that happens inside the guest. That's why Docker chose VMs for the sandbox. Of course, that isolation isn't free. A VM requires a full operating system with hardware resources, networking, package managers, all of it. So even Docker's micro VM requires gigabytes of memory, which is ironic. VMs being resource hungry is exactly why Docker containers became so popular in the first place. I guess in the age of AI, everything old is new again. That's the core architecture of the Docker Sandbox. Now, what's it like to actually use it? Let's take a look at the practical side through the developer experience and the tooling. Let's start with what the VM architecture means for your coding agents. Inside each Docker Sandbox is a completely private Docker daemon. Your agent can build, run, and delete Docker containers completely separate from your host Docker environment. That means your agent can run code validation, debugging, or testing, or even spin up its own tooling as needed without any risk to your host device. Now, the agentic tooling. Two things really stand out here. First, file sync. Docker uses bidirectional file sync for files in your working directory, preserving your absolute paths. That means everything matches your host, whether it comes to relationship with these files, or outputs like stack traces or error messages. No mental translation needed. Second, credential injection. Remember how we talked about API keys and credentials being a risk? Well, Docker Sandbox uses a proxy to inject your credentials into the outbound API requests on the fly. The agent never sees the actual tokens, so even if the sandbox is compromised, your credentials can't be stolen because they were never in the sandbox. Another cool thing about the architecture is that the VM is built from a Docker file. You can customize the agent's tooling by creating your own Docker file. And if the agent doesn't know how to use these tools, you can extend their knowledge through frameworks like agent skills. For example, you could add Playwright CLI to the Docker file as a headless browser, and then add Microsoft's own official Playwright CLI skill in the project directory to teach the agent how to actually drive the CLI. You can also set network policies to let you control exactly which domains the agent can reach. I could, for example, only include my serverless Elastic project domain to the allow list and not let my agent touch any other part of the internet. Now, let me show you what the user experience looks like in practice. Hey, Future JP here. So since we recorded this video last week in late March, Docker's released Docker Sandbox as a standalone CLI tool called SBX. What you'll see past JP use here is the sandbox tool that comes with Docker Desktop. Slightly different syntax, but basically the same tool, so all the key concepts still apply. Both tools are available, so anywhere where you see me type Docker Sandbox, you could potentially use SBX as an alternative, but either is fine. Okay then, back to you, JP. Running Docker Sandbox is just one command like this. And you'll see that we've booted directly into the agent's interface, in this case Claude Code. This is now running in the VM, not on your host machine. Let's get it to run a task. And you can see that the agent's working here, so let's leave it to do its own thing. And meanwhile, if I open a new terminal tab and run Docker PS on my host, you get nothing. The sandbox doesn't show up. But if I run Docker Sandbox ls, there it is. So it's a completely separate management plane. And if I want to see what the agent's been doing on the network, I can run Docker Sandbox network log. This will give me a full breakdown of every request, what was allowed, what was blocked, and so on. And when we go back, we'll see it's done a bunch of things like install dependencies, built the project, and even run some tests. I've been using Docker Sandbox quite a bit in my personal workflow for a few weeks now. And I've really enjoyed the fact that I can trust it to work away without it running around and smashing up parts of my computer. The lack of unnecessary context switching really has helped me focus a lot more on my other work. So far, I've talked about how great Docker Sandbox is, but look, it's not without its drawbacks. The biggest one is just the resource overhead. While a lightweight container would use maybe tens of megabytes on disk, I found that even a fresh sandbox would use 5 to 6 gigabytes. Also, each sandbox is assigned 4 gigs of memory, with about 1 gig of that being used by the sandbox itself. So if you're one of those people, and you know who I mean, running a gaggle of agents in parallel, it's going to eat through your system resources pretty quickly. So you should really consider which agents need the extra guardrails and maybe only run those in the sandbox if you're going to be running multiple agents. Platform support is another potential sticking point. Me personally, I'm pretty happy because macOS on Apple Silicon gets the full micro VM experience. But if you're on Windows, well, support is labeled experimental. In other words, use at your own risk. And Linux users do get container-based sandboxes, which, as we talked about, means weaker isolation. There are also some side effects of being a separate VM. Adding a persistent environment variable requires you to stop the sandbox, delete it, and recreate it from scratch. That means losing your entire agent conversation unless you somehow manually back it up and restore it. One team called this a steep penalty for a small configuration mistake in their blog, and they probably have a point. Also, I've talked a lot here about isolation and protection, but you need to know that Docker Sandbox doesn't protect your project files. Your workspace is still fully writable inside the sandbox, but it has to be, otherwise the agent couldn't do its job. It also means, though, that the agent can delete your codebase and eat your work. The sandbox protects your system, but your project itself is still vulnerable to the agent. So keep committing your work and keep pushing it to a safe place. Docker Sandbox isn't the only game in town. A cursory search will show other providers building sandboxes on the cloud or building them as part of agents and frameworks. As with all things AI, the space is moving really, really fast. But Docker Sandbox does have a few key advantages. It's local, and it gives you a full Docker daemon inside the sandbox. Plus, it comes with the Docker desktop, so if you have access to that, like millions of developers, you already have access to Docker Sandbox. And they seem to be investing in the agent ecosystem pretty seriously. So they're building out an MCP catalog and toolkit and partnering with others for cloud sandboxes. It really seems like they're building a platform, not just a feature. I think sandbox infrastructure for AI agents is becoming as essential as container orchestration was maybe a decade ago. The question isn't should we sandbox our agents, it's how quickly can we sandbox everything, and what's maybe the right sandbox architecture for this particular agent. Docker Sandbox is a very accessible on-ramp with serious isolation. It's free if you have Docker Desktop, so it's easy to get set up and use, and it's quite customizable too as well. Look, I've been using Docker Sandbox for a short while, and I'm quite excited. I'm actually going to be playing in the sandbox a lot more in the future. One thing that I'm really excited to do personally is to use it with I'd also love to hear about your preferred isolation strategy for your coding agent. Are you like me and find Docker Sandbox a good solution for your use case? If not, I'd love to hear why and what else you use. Please let me know in the comments. That's it for me. Thanks for watching. Remember to like, subscribe, and tell your friends and pets. Okay, see you next time.